Hello everyone, welcome to this last part of inequalities with two variables videos. The last thing that I haven't mentioned yet is, remember how whenever we graphed on a number line with an inequality, and sometimes we would put a circle, but other times we would put a closed dot in graph? Well, you have something similar whenever you do the inequalities with x's and y's. I didn't mention it in the other videos because it's the last thing that you think about. First, you graph it by finding the intercepts. So I'm going to go ahead and graph number 1 by graphing the x-intercept, which is equal to 3, and the y-intercept is equal to -1. So I'll just put a dot for those two spots. X equals 3 on the x-axis, y equals -1 on the y-axis. Then, normally, we connect these two dots with a line, but whenever we're greater than 3 and number 1, that means we can't be equal to 3. If we remember, in a normal graph, whenever you're graphing like, let's look up here, x plus 2y is equal to -2, each combination of x's and y's, each of these two things, x and y, when plugged in, should equal -2. But here, we don't want them to be equal to 3, we want them to be greater than 3. So, that means, how do I highlight all of the answers that'll be greater than 3? Just like whenever we did these number lines, we just pick a random number. You pick something like 7, and you see if it works. But here, we can't just pick the number 7, we have to pick a coordinate. So we're going to check. We're going to check and see which side I need a shade. Are the answers above the line the right answers? Or is it the answers that are below the line that we drew that are the ones that are greater than 3? To find out which side is actually greater than 3, we need to pick a random test point. So I'm going to pick 0, 0. 0, 0 is always the easiest test point to pick when determining which side of your line actually is true for the inequality. So if I pick 0, 0, that means I picked 0 for x minus 3 times 0 for y. And I have to say 3 because that was the original number. So is 0 minus 0, which is 0, is 0 greater than 3? No, it's not. Since the number 0, 0 was not a solution, that means that nothing on this side of the line is a solution. We should pick something on this side and see if they're solutions. So I'll pick 6, 0, and we'll see if that's greater than 3. Six for x minus 3 times 0 for y, and we're checking to see if it's greater than, not 0, sorry, checking to see if it's greater than 3. 6 minus 0 is 6, and 6, is it greater than 3? Yes, it is. That's a check mark. So, 6, 0 is a solution, and so is everything else on this side of my orange line. Everything on this side of the orange line is a solution. Let me go ahead and put some arrows on that orange line. Are the numbers on the orange line a solution, though? If you were something, an x and a y, like the x-intercept here, that's something that was on the line. Are numbers on the line solutions? Well, let's check. It won't take very long, and then you'll never have to check it again. If I put the number 3 for x and 0 for y, because that's the x-intercept, do we get something greater than 3? 3 minus 0 is 3. 3, is that greater than 3? No, it's not. So, whenever you have that inequality symbol, whenever you have just greater than or less than, you do not include the numbers on your line. So what I'm going to do is I'm going to show, we want the line to be visible, but we don't want it to be a solid line because a solid line means it includes every number on that line. Whenever you make a dashed line, that means that that's just like a boundary. It would be a line if it was an equation, but because it's an inequality and we're not including the numbers in the line, in example number 1, we're going to use a dashed line. So let me just write that note off to the side. Greater than or less than symbols use dashed lines. Now let's go ahead and do the red example. Let me clear all this off, and then we'll do the red example. 4x minus 6y less than or equal to 7. Let's find the x-intercept first by putting 0 for y. That's going to give us 4x less than or equal to 7, which means x is less than or equal to 7 over 4. That would be the intercept. 7 over 4 is more than 1, but it's less than 2, and that's the x-intercept. Now let's find the y-intercept. We're going to put 0 for x. 6 times y less than or equal to 7. We'll divide by negative 6. We're going to have to flip the way the inequality points, and we'll have 7 over 6, and that's going to be a negative number. Y is greater than or equal to negative 7/6. Negative 7/6 is more than negative 1, but it's not too much more negative, so it's going to be like around there. Let's connect these with a line for now, and then we'll see if we need to change it later. We'll see if we need to change it for a dashed line later. Before we check the dashed line part, let's check and see which side I'm going to shade. Am I going to shade the numbers on the top part of this line or the numbers below it? Okay, well let's check a point, and that point we're going to check is 0, 0. 4 times 0, 6 times 0, less than or equal to 7. Is 0 less than or equal to 7? Yes, it is. So I just checked the test point 0, 0, and it was a solution to the inequality. That means that everything on this side of your graph is going to be a solution to the inequality. Now let's see if the actual numbers on the line are solutions. So that x-intercept is what I'm going to use. My x-intercept was 7/4. 4 times 7/4 minus 6 times 0 less than or equal to 7. The 4's are going to cancel, and is 7 less than or equal to 7? Well, it's not actually less than, but it is equal to, so it works. That means that numbers on the line are okay, so we're going to keep it as a solid line. Let me write that note down. When you have greater than or equal to signs or less than or equal to signs, use a solid line when graphing. If it's not equal to, then you use a dashed line. If it could be equal to, you use a solid line. You determine which side of the graph to shade, which side are the actual solutions, by checking a test point. So the steps for all of this again are graph like normal, check for solid or dashed line, And then pick a random test point. But 0, 0 is the easiest. If it's true, shade that side. Of graph. All numbers on that side are solutions. Okay, use those 3 rules to make your graphs for today.